Hey guys, people. I'm going to start another project. I'm still working on the Airstream, but this is like a little side project. One of the things that I really get tired of is setting up Christmas lights every year. I put up some rope lights to keep from doing Christmas lights, but they just don't cut it. They're only 16 colors. You know, they have remotes like these, and it's two 100-foot strings, or it might be 200-foot. One goes around one side of the house, and one goes around the other, and it almost goes around the entire house. But I want to do more with it. I'd like to do all kinds of colors and some of the fancy things that are out there. So I called a company. I got one of those hits on Facebook. Hey, try this company here to do these automated lights for your house. And I figured, well, I'd get an estimate. Let's see what they charge. And they came out and did an estimate of the entire house, and it came out to $16,000. So that ain't gonna happen. I could hear my wife in the other room telling the lady giving the estimate, "Is that a comma?" So, yeah, we're not spending that kind of money to do lights on the house. So I decided to start doing some research. I found another company that's here local that you just give them the measurements of all your sections, and then they'll give you all the lights, the track, and everything, with the computers and everything that you need all set up for your system and your house, and you install it yourself. That came to about $4,500, something like that. That was still too much. So I started digging. You know, I figured if I can build it myself, if I can install it myself, I could probably build it myself. So I started doing some research. I found out that it uses a single addressable LED. I'll show you what those look like. I kind of have them installed right now, but I don't have them installed, but I have them in a track that I've been starting to do some experimenting. So these are 12 millimeter single addressable LEDs that I put into a vinyl strip. I drilled holes that are 15/32 of an inch, and that's a perfect fit. They snap right into the hole, and then all the wiring is tucked inside, and then you have this screw slots to slide it up into the soffit and screw it into the fascia, the back of the fascia. This right here is one string of lights. It's 50 lights, 25 on each. They're joined together here on this end, and that's the one end. Here is the input, and then this is the output to go to another string. But how do you control it? Let me put this back. So, after researching, a string of lights runs one of those strings. You can get on Amazon for about 17 to 18 bucks per string. That one string does about 10 feet. So you have to measure all of your edges of your house to kind of get a determination of how much you want, how much lighting. If you have gables that you want to light up and edges, you'll have to measure every angle. And I calculated if each one of those strings, 50 bulbs for 10 feet, I'm going to need about 2,500 bulbs. So, you know, that's 10 strips is 500. So I'm going to need probably 50 strings of lights. So, anyhow, that's part of it. Now, there are some websites, and I'll put links to all these websites. AliExpress is one of them. Wish.com, you can probably find them on there. But I know AliExpress, I've seen them as low as $12 a string. So that reduces the cost. The other part is you'll need some wire. This is regular 18 gauge wire. And what this is for is basically to get from string to string. You'll need higher gauge wire depending on how many strings you put together. My setup, with as many bulbs as I have, I'm going to need some 14 gauge wire, and I'll need 2 power supplies. Now the bulbs that I got are 12 volt. If you use the 12 volt, you can get more out of a power supply, and then if you use the 5 volt. But you don't have to do your whole house with these. You can do under your countertops, or you can do in your kitchen. You can do these anywhere. You can do your Christmas tree with them. So with my setup, I'm going to have 2 power supplies, and I'm going to run these to 2 basically computers. And what I'm using is, and I'll put a link to these 2. I'm using these. These are called QuinLED. It's a guy that I'm really following now. I'll put a link to his site too. He designed these computers. This one is called a Dig Quad. It's a digital controller, and it has 4 channels. He also does a Dig Uno, it has 2 channels. Depending on what you need to do. This one's Wi-Fi. I'm going to actually take it. I bought it with the acrylic case. I'm not going to need the acrylic case because I'm going to be putting it into a junction box, which I'll show you. And right now I just have it wired for the 2 power supplies because I was just toying around with it and doing some testing. So I'm waiting for more to come in. These, if you get it like I got it with the Wi-Fi external antenna, they're like $42 each, and I'm going to need 2 for my setup. That's what I think I need now. I might need 3, I don't know yet. But I did order some extra. I think I ordered a total of 4, so I ordered 3 more. It also comes with an Ethernet, so it depends on which one you buy. You'll see the link. You can go in and look at whichever one you want to do. If you want to do it Wi-Fi, or if you want to do it with the Ethernet. If you want an external antenna, or you want an internal antenna. There's all kinds of setup. I think there's like 5 different configurations that you can get with the acrylic case and without it. Another thing you're going to need, these are standoffs, or these are for the junction box to install PCBs or circuit boards in the junction box and gives it about a 1/2 inch of height off of the floor, gives it room to breathe. These are high-low relays. You can find these on Amazon. I'll put a link to these too. They're 5 volt. What these are designed to do, from what I understand, is when they receive a signal, that they'll go ahead and signal the power supply to come on. This way you won't have the power supply on 24/7. There is my power supplies are 12 volts. These will handle 12 volts, but there will be a 5 volt power supply for the relay itself that I'll use a regular phone charger type of power supply, just 5 volts. And it doesn't pull that much power, so I'll just use one 5 volt power supply to run 2 of these relays, because I'll have 1 for each power supply. Then you'll need, I bought these off of another site. I'll put the link to it too, but now I look at them, they're pretty easy to make. They're just acrylic. What these will do, these will allow me to install 2 power supplies on top of each other, and then offsets them so that I have room to reach the connectors, or the input and output connectors. but it also separates them so that the power supply fans have room to breathe. Then you're going to need, these you can find on Amazon. These are just jumper wires to go to the end of the LED strips. And this is a 3-wire system, so it has positive, ground, and data. Data signal is the one that sends to tell each light bulb what to do. A lot of people set up. Now I'll tell you, when I first started messing with this, I started with this, and these are really cheap. They're like I think they're like $4 on Amazon, and it's called a Node MCU, and it's just a little circuit board that has a chip on it. This one is ESP8266 chip on it, and it has built-in Wi-Fi. The software that you use to control everything that I'm going to do is WLED. You can get that free online. You can put it on your phone. You can put it on your laptop. It's for Mac and iOS, Android, and Windows, and that's what controls everything. You can control every individual bulb if you need to. So what I did is I started messing with this until I found out about this. Now there are other controllers out there that I'm researching that are a lot bigger, 32 channel, 48 channel boards, controllers, but a lot of them are pretty complex. This guy has made this really, really simple. I'm a network engineer, but I don't know much about electronics, but he's made this system basically what we call in the engineering field idiot proof, mostly. So he's pretty much got the software built into it. These are ESP32. ESP32 chips. And he's designed these that they're 4 channels, and they supply to have 7 power outputs and 7 grounds and 4 channels, and then it has the 5 volts, which I'm going to be using with the relay to signal when to turn on and off. A lot of people who use some of this stuff, they'll buy the boards, and they'll buy these breadboards, and then they'll build their system, on one of these, like this. I'll turn around so the USB is out. Kind of like that, and then they'll put their positive and negative, and they'll do everything with jumper wires, and that's good for testing. But my plan is to build it out in a junction box. I've been watching a lot of people on Discord and how they're building theirs, because Quindor, the guy who designed these things, he's got a pretty good channel on there. And I'm trying to remember what his company name is. It's got it on the board. I just got to find it. Yeah, there it is. Intermit.Tech. So I'm gonna put all the links to it. These guys, I give these guys all the credit. I mean, follow them. I'll put links. There's another guy, DrZzs, I think it is. It's one of them that I bought some boosters off of. And they have these little 12 volt or 5. They do 5 and 12 volt boosters that allow you to take the data to a certain length of the strip and then extend it for, like, if you have a long haul to get to another side of your house, you can use this booster to boost the signal out farther out to that string. So I'm going to put all of their stuff in there, give them 100% credit for all of this, because I wouldn't have a clue how to do any of this if it wasn't for this guy and actually everybody involved. But like I said, I'll put all their links on the page. So this is just the beginning. Look forward to more videos on how to actually, how this is all going to be created. Because it's all a learning step for me. And I have to fit it in between my work and working on the Airstream. So, of course, whatever else pops up. And it's all DIY. So you can build this yourself. You can start off really small, especially with one of these Node MCUs. And then you can start off with a small strip. I think this thing, this is 5 volts. So you have to be careful when you get a power supply. You do a 5 volt power supply. This is 12. This will do 5 and 12. I think it's 5 to 24 volts. Yeah, this will do 5 volts to 24 volts. I'm doing 12 volt bulbs. It all depends on what kind of bulbs you do. But you can still do this with a 12 volt bulb. You just have to run your power supply to a converter to convert 12 volts to 5 volts to power this. And then you run 12 volts to your LEDs. Your data signal will come off of here to go to your bulbs. So, and then you just get on WLED and program it to do what you want. I got some sample lighting that I'll put up to show kind of what the testing looks like. And I got to build a jig for drilling the holes in those vinyl. Those are J-channel, vinyl J-channel that you find in Lowe's, 5/8. And just be careful when you buy your J-channels that you buy them all from the same place. Because I bought 5/8 J-channel from Lowe's, and I messed the first one up, drilling it, kind of used the wrong drill bit and messed it up. And then I went to Home Depot and bought 5/8 channel, and they're just a little bit different. So try to stay with the same manufacturer, same color, same size, same store, because they end up being a different manufacturer and they won't look the same. So if you have any questions, hit me up. You can still hit me up with questions that that you might have while I'm building this, and let me know what you think. If you're familiar with this, I'll take any help I can get. I've never, like I said, I've never done this before, and I'm kind of learning on the fly. And it's been a learning experience the whole time. I'm waiting for these boosters to come in. And this here, I'll knock over my tripod. This is going to be my junction box. We open this up, and my plan is, so it's going to be my junction box. My plan is I'll put both my power supplies down here, then put my my dig quads here and here, my relays over here, and if I do need the boosters in this, I'll probably put them up here, and then run my outputs up, which will go up to the attic. So these are my power supplies. I have to do another hole. It's going to be for the 5 volt power supply. That's going to come out to go to the relays. And that one power supply is going to supply both relays. I shouldn't need 2 different 5 volt power supplies for the relay, because it ain't going to pull that much power. Now, the one thing I had to find out that I had to do when I was experimenting, and you'll have to do this too if you've never done this before, is you get everything set up and you set up one string. Take a multimeter, and then if you don't know how to measure ohms, you take your multimeter, which I have one right here, and you have to find out how much power is your LEDs going to pull from your power supply, and how much your LEDs are going to pull from your dig quad, because your power supply, because see, I have 2 power cables here. This is going to be going to one power supply. Your power supplies have, like this one has 3 outputs, 3 grounds, or over here, 3 grounds, 3 outputs, and this is your input. It'll come from those cables going into the junction box. I'm going to wire 2 outputs so I can use 2 to 12 volt rails on my dig quad. So I'll have 2 here and 2 here. And then on the out here, over here is output power. So what I need to know is each one of these output powers, there's 7. Let's see if you can see that. So those red ones, there's 7 output powers. 2 of them, the first 2 go to one of those fuses. Second 2 go to the second fuse, and then the third goes to third, fourth, first 2, second 2. That's 4. And then the 5th one goes to the third fuse, the 6th one goes to the 4th fuse, and the 7th one goes to the 5th fuse. So I would not recommend wiring multiple powers to the first fuse, because that first fuse is only 5 amps. So each run from this cannot exceed 5 amps. When I did my string, those strings that I have right there, I maxed them out at full white at full brightness. That's the max power that you'll get them to pull. And I was pulling, I think it was like 1.2 amps. And now the guys who developed all this said that you don't really need to worry about that, because you shouldn't be running your lights at full brightness anyhow, because what actually happens is it tends to change. There's so much light that it changes what it looks like. I'm going to be using the lights that are about 2 inches apart. I want that holiday look. I want that kind of lighting. If you bring it up at full brightness, then they'll kind of melt together, where you won't be able to really see the separation because they're so bright. Everybody recommends running them about half. So when I turn it down to half, I get about 0.75, about 0.7 amps, about 700 milliamps. So that's what they recommend. Then you can go into WLED and tweak WLED to maximize, how much amperage you're going to use per LED. So I can set it to 750 milliamps per LED. If it exceeds that, the WLED won't allow it to go beyond that. It'll start reducing how much refresh rate, how much it's going to play. If you got a kind of, sparkly lights going on and zooming down back and forth, when you start to exceed the brightness, that'll start slowing down. It starts to compensate for the amount of amperage that you're using, so it won't maximize and go too far. So my plan is to keep it about, I'm thinking about between 50 and 60%, and then setting WLED to that amount. So with that, if I'm looking at 0.8 amps, I'm looking to think that I can probably get about 6 strips, which is about 300 LEDs. So then, because this handles 4 channels, that's 1,200 LEDs for one dig quad. I get a second dig quad, now we're talking 2,400 LEDs. So if not, and I look like I'm pushing the envelope on the amount of LEDs that I'm doing, then I might have to go for a third. One of the most important things is power injection. Once you get to a certain point out of the string, you get 300 LEDs out there, 6 strings, you may start seeing problems with the lights now down near the end. They might start to fade, or they won't really cooperate with the design or whatever you're doing with the data. So you'll have to do a power injection. So you'll be able to run off of you can put a fuse block in your junction box and run off the third run of your power supply, and then run a 12 volt, what they call a power injection, and add power to the end, or after 150, add power. And then as long as it's coming from the same power supply, it's running the same signal, it should work no problem. You should not intermix power supplies. So this one power supply will run this dig quad and all the lights in it, and this second power supply will run a second dig quad and all of the lights it's going to run. So my next part of this is going to be building out the junction box, having all the electronics in place nice and clean so that I can start calculating how much I'm going to need and where I might need power injection. So like I said, questions, no problem. If you have ideas and you know what you're doing with this, because like I said, I don't, let me know, help me out. I'm all game to take criticism, and I'll 100% give you credit for it, because I would really appreciate any help, any criticism. I don't have any problems with people telling me if I'm doing something wrong. One of the most important things is be extremely careful. You're dealing with electricity. If you have no idea what you're doing and you're very scared about doing it, just make sure you get a professional. I'm pretty confident with what I'm doing with the basics. You know, I'm pretty confident with myself with electricity, and so I'm not too worried. So give me a holler, give me a follow. Talk to you later.